Hello friends, this is Balaji and welcome to Bhavishya Mark, exploring facts with futuristic thoughts. In this episode, we are going to build a custom 3D printer from level 0 to level 100. Come on friends, let's see how we are going to build it. So, what is our goal in building this 3D printer? So, what are we going to do with this 3D printer? Well, that's a big question. Some do business with this 3D printer. Some do it as a hobby. We do it as do it yourself and make others do it on their own. So this is what we are going to achieve. Building a custom 3D printer? Well, it is easier to build a custom 3D printer when you have the right raw materials and when you get it from the right place. So I've managed to gather all the raw material from one place, and I'll share you the link from where I've received the raw materials. And by no means this video is being sponsored by that person or by that company. So let's go ahead. We need to get the raw materials from one place to make sure all fits hand in hand. Your configurations, your alignments, all your other parts in the 3D printer needs to go hand in hand. For example, when you wanted to build a 3D printer using CR10 or CR10S, getting a raw material from the same company gives you an edge where you can make sure that the built 3D printer will look exactly like a CR10 or CR10S. Similarly, getting the 3D printer raw materials from a single company will help you in a great deal. Apart from the mechanical raw materials, you need to get the electrical raw materials as well. Nothing but the Arduino Mega board, RAM's 1.4 board, stepper motor drivers, hot end fans, layer fans, etc. I'll share you the link in the video link description so that it's easier for you to buy. Okay, once you've gathered the raw materials, the next step in this is to construct your frame. For a frame construction, effectively you need the aluminum extrusions, your screws, your either inner joint or an L clamp to fasten and tighten the aluminum extrusions. I recommend going for an inner joint because that is more secure. And in the later part of the video and my build of 3D printer, I've turned myself from an L clamp to an inner joint. This frame construction is a very important one. The reason is once you have constructed your frame, there's no turning back because once you've constructed your frame and over the frame, you start assembling all your axes like x-axis, y-axis, and the z-axis. You can't disassemble because of a misalignment in the frame construction. So in the image that you are seeing here, you can see the x-axis, y-axis, and z-axis, how it has been constructed over a frame. That particular image I fetched it from an internet. So based on that particular image, we have to start building all our requirements. Let's go through my frame construction. If you see the measurement between the z-axis, it's 420 mm. When it is measured up and when it is measured down, it is exactly 420 mm. This is certainly required to make sure the axes are perpendicular. The y-axis and the z-axis needs to be exactly and perpendicular to each other. And the total height is 460 mm as in the measurement. The y-axis measurement is 420 mm as well. I have constructed the x-axis successfully. I've constructed the x-axis using the palm wheels, eccentric nuts, GT2 pulley, idler pulley, and everything. And I've added the motor as well. And as you see, you need to construct it in a way that it perfectly fits in the aluminum extruder for the rolling. If you see the way it has been constructed, it needs to be perfectly aligned. The x-axis needs to go up and down very freely so that it has no gap whatsoever. And you need to make sure it is exactly parallel to the y-axis. This one and this one needs to be very parallel. In this step, we will just go ahead and add the lead screw for the z-axis. Assuming that you have constructed your frame perfectly, x-axis perfectly, now we'll go ahead and add the lead screw. When you wanted to add the lead screw, you need to have a special type of coupler which is called the flexible coupler. This flexible coupler is the one which connects your stepper motor to the lead screw. Your lead screw diameter is 8 mm, your stepper motor diameter, shaft is diameter is 5 mm. So the coupler needs to be a 5 mm to 8 mm coupler. Once you add this particular coupler, the next step is to make sure that this coupler is exactly parallel to your z-axis. That is, your lead screw and your z-axis frame should be parallel, and your lead screw and your y-axis should be perpendicular. The most important construction step is this one. Once this is done perfectly, all the others will fall into place at ease. As you can see, I've added the coupler, lead screw, idler pulley, this lead screw sitting in the x-axis, the palm wheels, the stepper motor, GT2 pulley, the idler pulley on the both the ends. And if I am going to rotate the lead screw, the entire x-axis is going to come up and down. So this is most important step in the alignment and balancing of this particular frame construction. We will go through the bed placement and leveling. The bed placement needs to happen in the y-axis, and the bed leveling needs to be done with the leveling screws. These leveling screws needs to be placed in the four corners of the bed so that it can be leveled properly in the future. And the bed needs to move freely front and back in the y-axis so that we don't have a problem in the future for the movement, and we don't have problems with the stepper motor trying it very hard to move it. And if you see, I've also placed the extruder motor in the top right corner. A perfectly leveled bed will look like this. Once you level the bed with the leveling screws, you can take a spirit level and start measuring whether the balancing and the levels are perfect. So you need to measure on all the four corners so that the spirit level is in the middle. And you can mention diagonally as well so that it is all perfectly level. End stops are equally important. There are two categories of end stops. One is a mechanical end stop, other is an optical end stop. I chose an optical end stop. These end stops can be placed in six different positions: X-min, X-max, Y-min, Y-max, Z-min, Z-max. I've chosen to place the end stops in three positions. One is X-max, Y-max, and Z-min, and these end stop needs to be placed in a way that it can be properly intruded so that the traveling of that x-axis, y-axis, and z-axis can be perfectly aligned and properly calibrated. The bigger challenge is to place the why end stop, because in some situations we need to do a rough calculation and try to place the end stop because our z-axis is fixed and the x and y are the moving axes, in which the y-axis is sitting below our bed, so that it's going to be really a challenging task. So I suggest you remove the hot bed and fix the y end stop, and then try to add the bed again. If you see in our case, I have placed the y max end stop in such a way that it is underneath the bed and it is not hindering any of the other existing components, and it is perfectly aligned. And thus we reach the level 50, which is nothing but the conclusion of the mechanical build. We now need to move on with the board and the connections. Follow this particular diagram for your end-stop connection, heat bed thermistors, LCD display, x-axis, y-axis, z-axis, stepper motor, hot and fan, power supply, bed, layer fan, heat, heater, which is for the hot end, and the extruder stepper motor. Yes, I think you've gone through the wiring details. There are multiple sites available in internet, as well as multiple channels available in the YouTube, where you can find how to do the proper wiring. I'm not going to bore you with all the details over there. Rather, let's jump in to see how this custom 3D printer is printing the Calicut. As you can see, the Calicut is trying to take its shape from level 0 to level 100. This is a simple project that I have done to showcase that you can build your own 3D printer. Thank you.